Welcome to the new series AI Busters. In this series we will be building our own AI projects. Everyone telling you that AI will take your job. What about you taking her job instead? The first AI project will be a game named PONG. We will be creating that game. Then we will be learning our AI what the duck is PONG. And after that she will understand what the duck is PONG. And finally you will have your whole AI-PONG game that you can show to your friends or family or anyone else. You can flex that you have your own AI game. So without further ado, let's make the history. The first episode will be about building PONG in Pygame with Python. In the end of this video we will have this PONG game built by yourself, and also you will improve your object-oriented programming, so it is worth it. Okay, let's go to code. To kick things off, we will create Pygame window. The whole code will be available in the description on my GitHub. And also subscribe if you like this video. I will start by importing the Pygame library. To run the Pygame window, we need to initialize it. I will define the main function where we will be running our main loop. This loop is for running the whole game. I will press here running is equal to true. We will get here in a second, but before that I will initialize the window for our Pygame by pygame.display.setMode, and here I will enter a tuple with width and height. The width and height is not defined yet, so I will define two constants, the width and the height. The width will be 700 and the height will be 500. Now we need to display the window somehow. I will display it in the main loop. This will be the main loop. I will fill the window with a color, black. Black is also not defined, so I will define black. Black is color with none of the red, green and blue, so it's 000. Now we will update the window with Pygame display update. And if we got out of this while loop, we need to quit the Pygame, so pygame.quit like this, and if main is equal to main, we need to compare this, not assign value, so this colon, and we will run the main function. I did a little mistake here. The name of this file has to be main, because this means we can run the main.py file only directly. We are not able to import it as a module and then run it. And the last thing before I show you the Pygame window, we need to close it. We need to get out of this loop somehow. So I will create another loop which is called event loop. For event in pygame.event.get, to get the event, if event.type is equal to pygame.quit, that means we are trying to close the window, the running will be false and it will jump off this loop and we can quit the game. Save the program, run it again, we have a Pygame window. Now let me make few adjustments to make it more beautiful. I will comment this like green dimensions. Also I will define the white color, so colors white will be 255 and 255. Then I will define the caption of our game, so pygame.display.setCaption. I will call it AI-PONG. Our game needs some clock to handle events and know what time is what object is moving and so on. So clock will be equal to pygame.time.clock function, and we will run the clock.tick on our FPS frame per seconds. Here I will define it in the game settings that FPS is equal to 60. That means that our game will be running on the same FPS or less in every computer. Now run the code again, and here is the title, and our game is doing nothing yet, but don't worry, we will create the pedals and also the ball in the center and the scoreboard. That's our next goal. Let's go. Close the window, and to create our pedals, I will define a class with the name pedal. It will be a blueprint for any instance of this class, any pedal. Class to represent a pedal. We'll be also moving this into class name game in a bit, and in the end we will be calling only the instance of the game class. I'm getting just ahead, but it's okay. We are focusing on the pedal right now. To define a class, you need to define the constructor, like the main attributes of your class and the instances from the class. Here you need to specify the self, the class itself, the instance itself. Our pedal will be a rectangle, so we need to define the x, y, the width and the height, and also the color. The color of the pedal will be white. Here in the constructor, it is a convention to write self.x is equal to x. That means that x will be the attribute of that class. That x will be the x of that class object. Understand? Okay? So self.y will be the y, and self.x will be equal also the self.x star, because we need to save the starting position. This will help us with resetting the starting positions of the pedals. So self.y start is also equal to y. Self.width is equal to width. Self.height is equal to height. And last but not least, self.color is equal to color. We need to draw the rectangle, so define another method called draw. Here I will define the object itself and all the attributes that are encapsulated in that object, and the window we wanna display that rectangle. So pygame.draw rectangle. Here I need to define the window, the color, and pygame.rectangle, and enter the tuple with the starting position, so self.x, self.y, self.width, and self.height. And in the main function I will define two instances of our class. The left pedal will be instance of the pedal class, and the starting position of x will be 10, so 10 from the left side of our window, and the y will be, okay, I do not have width and height of the pedal defined yet, so I will make another section for pedal and ball settings. Pedal width will be 70, and pedal width will be 30, and pedal height will be 70. Now we will come back to the left pedal the y starting coordinate of our rectangle will be in the, no, it won't be in the middle of the screen, but it will be in the middle of the screen minus the half of the height of our pedal in order to make the pedal in the center. I will show you the height divided by 2, so we are in the middle, minus the pedal, this is the height of our window, minus the pedal height, also divided by 2. So the center of the pedal will be in the center, and its width will be the pedal width and the pedal height. The next pedal will be the right pedal. Right pedal is equal to pedal. This pedal will be 10 pixels from the right, so we need to do width minus 10, but also minus the width of the pedal width, because the starting position of the rectangle is always on the left. It will draw the pedal, and then we need 10 pixels from the corner, from the right corner. The height will be the same as with the left pedal, comma, paste it here, and the width will be pedal width and pedal height. To draw this object, I will draw them here after our event loop. Left pedal dot draw, call it method, on the window, and also the right pedal dot draw on the window. Run the code, nothing happens. I find the mistake, it is silly one, because I draw the pedals and then fill the window with a black color, so I need to switch and run the code again. Here we have the pedals. Now we will draw the ball and the scoreboard. After that we will implement a move method for all the objects except the scoreboard. Yeah. So closed, and now it's time to implement the ball. To implement the ball, we will define another class named ball. This class to represent the ball. The same as with the pedals, we will define the constructor self x, y, and in the ball we don't need the width and height but the radius of that circle. The last one will be the color, also equal to y. Define it like this. Self.x is self.x start is equal to x. Self.y is equal to self.y start is equal to y. Self.radius is equal to radius. Self.color is equal to color. Also the draw function for the ball, self, and the window. Self, window, Pygame, draw circle on the window, self.color, and here tuple of the middle coordinates, self.x, self.y, and the radius of a ball. I will define it in here in the ball settings. Ball radius is equal to 7, for example. We have defined the ball class. Now we will declare it in the main loop and call it like here. Ball. We also need to create, before declaring the ball, we need to create the ball object. Ball is equal to ball, so instance of the ball class. Ball will be in the middle, so width divided by 2, height divided by 2, and the radius will be the ball radius. Now it's time to declare the ball, a ball dot draw on the window. Run the code, and as you can see, ball is here. Before drawing a scoreboard, I will transfer every instruction that have something with a game to a class called game. The game class will be handling everything. The game class will be handling the whole game. So class game, like this, colon, class that handle the Pong game. Here I will define the constructor, init, self, only the self. Here I will put this 6 lines. Like this, and right here it will be this window will be attribute of that game class. Same apply for other attributes. Self.right pedal, self.ball. Now I will define the score. Self.right, I will start with the left. Self.left score is equal to 0, and self.right score is equal to 0. We'll delete this from here. This doesn't work right now, but I will move it also to the game class. Then I will create the instance of the game class and call it call the main loop through the game class. But before that, I will display the scoreboard. Here I will define the draw scoreboard function. It will not function method. It will drawing the scoreboard. The scoreboard needs some font. Therefore, I will define it here. Score underscore font is equal to Pygame font dot this font comic sans, and the size will be 50, not 59. Now we can draw the scoreboard. We will initialize the text, then we will put the text into the scoreboard and we will visualize it. So scoreboard, not scoreboard, score, left score text is equal to score font that render what I want to render there. The string, the left score itself, like this. The second parameter, we are just creating the score, we are not putting it on the surface yet. This one is for anti-aliasing, it makes the text more smoother. And the last one is the color will be white. The same we will do with the right. For text is equal to core font that render the string through the f string, the self that write score, anti-aliasing, and the white color like this. Now we will put the text on the window itself. So self.window bleed, it stands for bit block transfer. It will transfer this text onto the window. So what we wanna bleed the window is the left score text. Where we wanna bleed it, like the placement. So width divided by 4 minus the left score text that get width divided by 2. So it is in 1/4 of the window, and we will center the center of text to the center of the 1/4 of the window. And the height will be 20, like 20 from the top of the window. Same applies for the right score, so select that window, bleed, right score text, and width. But now we wanna bleed it to the other side, so bleed multiplied by 3 divided by 4, so it is in the 1/4, but from the right side, and minus right score text get width divided by 2 to center the text, and also 20 pixels from the top. I think this is everything for this function. Now we need to transfer this main loop to the game class. First of all, I will transfer the event loop. So define method handle events. The instance itself, colon, copy this here. It will not changing the running, but it will return false in this case, this with capital F. Otherwise, it will return true. It will do the same as the running boolean variable, but you will see. Now it's time for transferring this into the class. This will return true, and it will be saved into that running variable. So I will define run method. The self parameter here will be the main loop. I will copy that here, right there. What to do now? Delete this. We need to fill the window. So self.window.fill black. We need to draw the objects. Self draw scoreboard. We need to draw the pedals. Self pedal, the left pedal dot draw to the self.window, and self right pedal draw to self.window. After one iteration of drawing, we need to update all of this, like copy, paste here. We need to update the window, and we need to handle the events if the player need to exit the game. So handle self.handle events, self.clock fix FPS, right here the clock, and delete this. And if we got out of that while loop, I will quit the game. Pygame quit. Now delete this, and I will create an instance of a game class and call it game with a lower case g. It will be instance of the game class here, and I will run the game. I'll try to run the code. I think it will work. It do not work. So where's the problem? So I found the mistake. There are two of them why the font doesn't work. We need to initialize the Pygame. I don't know why the window is working without that, but it is. And the second one, we found the brackets here. I found these brackets because we need to just multiply it before we make the integer division. Like, you know what I mean. Now when I run the code, it should be working. Yeah, as you can see, it is working, but we need to display the ball. Okay, it is not working. It is not working that well because we need to this return true and return false we need to put in the running bool variable, and we need to also display the ball. So ball dot self dot ball dot draw self dot window. I will check quickly. Yes, we need to define the window, run the code, and as you can see, now it is working finally. We have the ball, the scoreboard, and the pedals. It looks like a mall, but it doesn't matter right now. It is time to make things moving. Close the window. It's working also. To move pedals, I will define another method in the pedal class. It will be called move, and I will put here self, the direction. If direction which will be put as a parameter will be up and self that y will be greater than 0, we will self that y minus self that y self that well self that okay. I need to define the velocity of the pedal also. Self that well is equal to 4. That means if we wanna go up and our pedal won't get over the top of the window, we will subtract the velocity of that pedal from that place where the pedal is. If direction is equal to down, we wanna go down, and self dot y plus self dot height is lower than the height of the whole window, we will put self dot y plus like this plus velocity of that pedal. We need to handle this movement with the keys on our keyboard. I will define a method in the game class. Define handle key input. Put here the game instance. To get a key from a keyboard, I will define a variable keys, and you can do it like Pygame dot keys get pressed, call it, and if keys pressed. And to differentiate between different keys, you need to write it like this. If keys is a list or something like that, and it have convention in the Python, like in Pygame dot key, and what key is pressed. We will call a function, call a method of a pedal, self dot left pedal dot move, and we're gonna go up. Elif keys Pygame key is S. We will go down, self left pedal move down. Elif keys Pygame key, and up is for the up arrow, self right pedal move up, and the last one keys Pygame the key down arrow colon self that right pedal will go down. I will run the code and the pedal should be moving. Now I cannot run. I also need to call this in the run method. So I will call it after the running self handle key handle events handle key input call it like this, run the code, and there's not attribute key. I have a mistake here, it is not pygame.keys, but pygame.key. Run the code. And now if I press up, down, arrow, the pedal is moving. I cannot go over the window, and same applies for the left pedal. The next thing will be moving the ball and handling the collisions with the pedals. Moving the ball will be more difficult because we need to handle the collisions, but don't worry. First of all, define the self.max. Well, maximum velocity of ball will be 5. Self.x will be, I will import random to make the ball go randomly to the left or to the right. So where I finished, self.x velocity will be random.choice squares like this, and it will be 5 or -5. And the starting self.y well will be 0. Now we will be defining the method def move. We need to change the coordinates, so self x will be plus the self x velocity, self y will be plus y velocity. So in the beginning, every tick of our clock, the ball will move 5 pixels to the right or to the left. Before I will show you in the program, let me implement the collision function. If we hit the top, it will bounce from it, or we need to implement this method to bounce from the pedal on each side. So define handle ball collision and self here. I will implement this with this print screen because there is a lot of math, as you can see, and it will take me ages to like make it from scratch. So at least I can explain you why I did this like this. Okay, so if self ball dot y plus self ball dot radius is higher or equal to high, that means that ball hit the top of the window, or self ball dot y minus self ball dot radius is lower or equal to if self ball dot y plus self ball dot radius is higher or equal to height of the window, it will hit the bottom of the window, or self dot ball y minus the radius, because the ball hitting the top, but there is a radius of that ball, it is not the center point only, so minus the self ball dot radius is lower or equal to 0, it will hit the top. Then I will change the ball y velocity like this, and it will bounce from the top or bottom with the same angle as it hits the bottom or top. Next thing is collision with the pedals. Self.ball.x well is lower than 0, not that well, underscore well. That means the ball is going to the left, and self ball.x minus self radius is lower than self left pedal x plus self left pedal v. This means that the ball, like the pedal, is drawing from the top left corner and you need to add the width of the pedal to that top left corner, and if the ball going over that pedal in the X coordinates, it will go to the other side. Yeah, but we need to manage also the Y coordinates, so if the ball is between the top of the pedal and the bottom of the pedal. There is another condition for this, so that ball.y is higher than self left pedal.y and self ball.y. That means it is lower than top of the pedal, and self.ball.y is higher. The coordinates of the windows are upside down from the higher, like top is have the lowest coordinates and bottom have the highest coordinates, so it is kinda shady right now. So the second end is for if the ball is higher than the bottom of the pedal, self.left pedal y plus self.left pedal height. That means it is from the top left corner plus the height of the pedal, so it is the bottom of the pedal. We will change something. We will change the X velocity to the other side, so it will bounce from it. But we also need to change the Y velocity, and it will depends on where the ball hits the pedal. So I will count the middle of the pedal just by self.left pedal Y plus self.left pedal height divided by 2. So now we are in the center of the pedal. The difference in Y between the ball Y and the middle of the pedal will be stored into this variable. And now with that we gonna calculate the reduction factor. It will be equal to self.left pedal height divided by 2 times self ball max velocity. We will divide the pedal into our max, where is it? We will divide the pedal. Our max velocity is 5. The pedal height is 70. It will divide the pedal into 2 parts, upper and lower, and these 2 parts it will divide into 5 parts, and it will calculate from which angle the ball will bounce from the pedal. It cannot bounce from the same angle as it comes to the pedal, because the ball will always have the same angle. But if we hit the corner of the pedal, it will bounce with the highest possible angle, so the Y velocity will be 5. And if it bounces from the center, the Y velocity will be 0. That's all. So also self ball Y velocity is equal to minus difference in Y divided by reduction factor. As I said, it is upside down. The top has the lowest coordinates and bottom has the highest, so there is the minus here. I will do the same for the right pedal. I will put this on the full screen and copy this here. I could put it in the function, but it is alright for this code. Here, what we need to change? So if the ball is going in the other side, yeah, and ball is going to other side, so here is plus the radius is higher than the self pedal minus the pedal width. No, self, only the self pedal, because it is drawing the pedal from the left, top left corner. This is X coordinate, it changed, but the Y coordinate is the same, so I will let it like here. And now, what to call? I can call the move from the ball and the handle collision here in the run method, but I won't do it. I will define another method. It will serve us in another purpose also, but don't worry about it right now. It will be named update game state. Here self. I'll write self.ball.move and self.handle collisions and save it. Move the ball after receiving the key. So self.update game state brackets, run the code. Run the code. This. Oh my god. Something I don't track. As you can see. What the hell? I did a few mistakes, as you can see. Okay, was wrong. Okay, I see one problem here. This is applied for a left pedal, this should apply for a right pedal. So I will. Where is the first left pedal? I will go here. Plus Ctrl plus H. And I will replace it with the right pedal. And press enter. Here. Okay. Now we can run the code again. I don't think we repaired everything, but let me try. I think it is working, but when the ball goes over the window, it will come back because of this condition. And we need to write something that will, if the ball go out of the window, it will give a point to a player on the opposite side. And if the player will earn enough points, he will win the game. Let me implement that. So here, if the self.ball.x is lower than -20, I will take a little time to reset. The score is where? The score is here. So if it's on the left, the right player scored. So self.score, right score, +1. There is missing if self.ball.x is higher than the width +20, then self.ball.x, self.right score, self.left score +1. Here is the score update. Now we need to reset the ball and the pedals. I will define functions to the pedal and the ball. Define reset to starting position on the self argument. The self.x, the current self will be the starting self. The starting x. Self.y will be the starting y. Self.y start. Okay, that's good. Also for the ball, define reset to starting position self. Self.x will be the self.x start. Self.y will be the self.y start. Self.x velocity will be the random choice every time someone scored, 5 or -5. The velocity of y in the beginning is always 0. So I will copy and I will reset all the pedals and balls. So left pedal, no, only self that left pedal, that reset starting position, self that right pedal, reset to starting position, self that ball, reset to starting position, self that, I will copy this here. Okay, that's good. Now if I run the code, it should reset, but we won't have a winner. Yeah, as you can see, it will. I do not reset the ball. Why do I? Yeah, mistake is that I'm not calling the method. I'm just write the declaration here. So if I run the code, it should be working. Yeah, the goal and the window reset. So if I give a goal, the window reset. So it's working fine, but this is infinite loop right now because no one can win right now, because I can give 100 goals and it won't be enough, so I need to do something with that. I will define a constant named winning score. It will be number of goals needed to win the game, equal to 3, for example. You can change it anywhere. You can change it anytime you want. And define the last method. Define the display winner. Put here self. And if self that left score is higher or equal to winning score, that means that winner text is equal to left player 1. Otherwise, if the right score is higher than the winning score, the winner text is equal to the right player 1. Else it will return a mistake. Now we need to render this text and put it on the window. So text is equal to scoreboard is equal to score font render the winner score, make it smoother, and the color will be white, not wild, but white. To self that window, that grid, text, and the width of the window minus text get width divided by 2 to put it in the center, and the y coordinate will be height divided by 2 minus text get. Okay, one more this bracket, get height divided by 2. I will update the display to make the changes visible. Update Pygame time dot delay to make some delay for player for rest. It's fine. It's 5000, and reset the scores. The left score is equal to 0. And so that right score is equal to 0 also. I will put here I will put 2 because I wanna showcase you the game. I don't wanna make it like 2 hours long. 2 hours longer than this video is already. Let me call the display winner here. Tell that display winner, and if I run the code, it's probably done. Yeah, it is done. Let me see, I will give a goal, okay, and the second one, it shoot right here, right, player 1, but I cannot exit the game, or can I? I have a mistake somewhere, again. Okay, I don't have a mistake, it was only a bug, because if I... Here, 2 goals, right, player 1, if I wait 5 seconds, it will reset the game, and it is done. Now you can play with your friends, and in the future we will be training an AI on this game. So subscribe if you enjoyed this tutorial, and in the next episodes, that's where we will be creating the AI. We will be having so many funny moments that it won't work again and again, but in the end it will work, and you will have your first AI game ever. So stay tuned, hit the like button, subscribe, write something nice to the comment section, and have a nice day. Peace.